Hi everybody, welcome to on Mathmax tutorial. Today we have seen what questions on integration, and today example on integration is integration under root 1 minus root x divided by 1 plus root x raised to power 1 by 2 dx divided by also x. Now if you want the simple solution, to watch video till at the end. Okay, now let's do start and think about the which method is best for this example. Okay, I can consider here the substitution method. Yes, okay. Therefore, I can here substitute. Suppose root x is equal to, I can put cos 2 theta, and this function difference both squaring on both sides. So we get here x is equal to cos square 2 theta, and this is the also function differentiate with respect to theta. We get here dx is equal to, we get here 2 times cos 2 theta. Again derivative of cos 2 theta is minus sine 2 theta into 2 and d theta. Therefore we can simplify this term minus 4, and we can write as sine 2 theta into cos 2 theta, and then above the integral become as simplify as I can write integration 1 minus cos 2 theta and divided by 1 plus cos 2 theta. Yes, okay, bracket complete raised to power 1 by 2, and we know that the dx is equal to, this is term minus 4 times sine 2 theta into, we can write cos 2 theta, and divided by x term becomes as cos square 2 theta, bracket complete, and d theta. And we know that 1 minus cos 2 theta and 1 plus cos 2 theta related formula. Therefore I can write 1 minus cos 2 theta is equal to 2 sine square theta, and 1 plus cos 2 theta we know that 2 cos square theta. Then this integration above becomes as, this is the, I can write 2 sine square theta and divided by, this is 2 cos square theta, bracket complete raised to power 1 by 2. Now here observe, this is the term minus 4 sine 2 theta, and this term cos theta and one term is cancel, and only remaining this is the cos 2 theta, bracket complete, and d theta. Yes, okay. Therefore now again simplify this term. Therefore 2 to here get cancel, and I can write as sine square theta raised to 1 by 2. That means this is, we get here only sine theta and divided by only get here cos theta, and in multiple minus, this is the 4, and we know that sine 2 theta is equal to, I can write sine theta into 2 times. Yes, okay. Here I can write 2 times sine theta into cos theta, and divided by also, this is the cos 2 theta and d theta. Now here we observe this term cos theta and this cos theta get cancel, and we get here I is equal to simplify term minus 8. Yes, okay, minus 4 into 2 minus 8, and sine theta into sine theta we get here sine square theta, and divided by, this is the cos 2 theta and d theta. Now we know that the related formula for these two terms, I can write here cos 2 theta is equal to, we can write 2 cos square theta minus 1. Okay, and sine square theta is equal to, we know that the cos square theta minus 1. So about this integration I can write minus 8 integration, this is cos square theta minus 1, and divided by 2 cos square theta minus 1 and d theta. Now I can here throw out divide and multiple by minus 2. Therefore we get here minus 2 minus 2. Yes, okay. So here we can cos square theta minus 1 and divided by, this is 2 cos square theta minus 1 d theta, and this term becomes as, this is the 4. Yes, okay. And this term we can write as, this is the minus 2. That means this term 2 cos square theta minus 1 can write minus 1. Yes, okay. And divided by this term as 2 cos square theta minus 1 and d theta. This is the arranging. Yes, okay. Therefore this term is equal to 4. In bracket I can write here 2 cos square theta minus 1, that means this is 1, and minus 1, this is the 1 upon term becomes as 2 cos square theta minus 1 and bracket complete and d theta. Yes, okay. And now we can find the solution. Yes, now we can simplify this term, and I can write here I is equal to, this is the 4 times in bracket integration 1 minus 1 upon and 2 cos square theta minus 1 is equal to also cos 2 theta bracket complete and t theta. Therefore again this term simplify as, this is integration in bracket 1 minus 1 upon cos 2 theta, that means this is a sec 2 theta and bracket complete d theta, and now I can find the integration. Yes, okay. Therefore we get here 4 times, this is the integration of 1, that means this is the theta, and integration of sec 2 theta, that means this is the ln sec 2 theta plus tan 2 theta and bracket complete. Yes, okay. And this is also 1 by 2 here term, derivative of 2 theta. Yes, okay. And plus is constant of integration. Yes, okay. And now I can simplify again this term in terms of x. Okay. So here we know that the root x is equal to cos 2 theta. So we can find the theta is equal to value. So this is the 1 by 2 actually term, this is cos inverse becomes root x is equal to theta. Yes, okay. This is actually value for theta, but we know that the sec 2 theta plus tan 2 theta, what is the exact value? Yes, okay. Therefore we know that the sec 2 theta is equal to root x, and I can write here sec 2 theta is equal to, this term becomes as 1 upon root x. Yes, okay. And tan 2 theta is equal to, we know that value, so tan 2 theta is equal to, we can find sin 2 theta divided by cos 2 theta, but we know that sin 2 theta we can write as under root 1 minus cos square 2 theta, so this becomes as 1 minus, and we know that cos 2 theta is equal to root x, that means this is the root x, we can square here. Yes, okay. And we get here 1 minus x value. So this is under root 1 minus x and divided by cos 2 theta is equal to under root x. Therefore this integration we can write as 4, then theta is equal to, we know that this is 1 upon 2 cos inverse, this is root x minus this is 1 by 2 ln, and cos sec 2 theta is equal to 1 upon, this is the root x plus, and tan 2 theta is equal to under root 1 minus x and divided by root x and plus is constant of integration. Yes, okay. And so final solution we can write as I is equal to 4 multiply throughout this term, then we get here this is the 2 times cos inverse root x, then here we get minus 2 ln, and we write as 1 upon, so we can write as only 1 plus under root 1 minus x divided by root x and plus is constant of integration. Okay, and this is actually my final solution. Yes, okay. If you like, then share and subscribe my channel. Thank you for watching. Bye bye.